Opcodes. Continuing legwork. Implement the following opcodes. 6 opcodes. See, I'm weirded out by this. Why? Why 6? I have a whole byte encoding my opcodes, and I'm gonna be implementing just 6 of them in the ALU. That's, again, this is the same as Overture. Huh. I hope at some point we're gonna extend the architecture for this one. The opcode not ignores the second argument. Okay, well, I'm definitely building this as a custom component. So you know what I'm gonna do? So that I don't have to switch back and forth. I'm gonna write it down. Add sub and or not XOR is what I need to do. Right, this is gonna be my small window. And I guess let's build it. Shouldn't be difficult. Okay, not schematic. Component factory. Cool. We're already at the ALU, but we're not gonna change my ALU. I'm gonna copy it. And I'm gonna say ALU, because I really like the name. Advanced ALU. Advanced Arithmetic Logic Unit. Even though it's not actually advanced at all. Okay, so how many is this? 1, 2, 3, 6. 1, 2, 3, 4, 5, 6. I can just reuse this entirely. Except I just need to switch these things up. Yeah. Okay, but actually, I've been thinking about this, and I think this might be a good time to actually optimize the ALU slightly. So at least, let's first build it. Let's first just build the naive implementation. This is annoying. I'm gonna redo this whole part because that's gonna be easier. After condensing it to that tiny space, it would be too difficult. Okay, so we want addition. We want subtraction. So addition plus mathematical negation. This is not bitwise not. This is negation. We want and. We want or not XOR. Or not XOR. Right? Okay, I'll wire this up. So this is what we have. It's just the inputs into these gates. But I've been thinking these adders are huge things, right? A single adder is, I don't know, I counted at some point, it was like over 50 gates inside of it. You know, 50 basic things. So perhaps instead of doing this, I could use a single adder, like so, and the input to it would always be this guy, right? It's always this light blue. It's always the first input does not change. However, the second input can be either, well, let's do it like this, I guess. The second input can be either negated or not negated, depending on whether we're doing addition or we're doing subtraction, right? So who decides whether we are adding or subtracting? Well, they would be piped into these two, right? Outputs. And these two outputs are decided by this mux, which I could actually, I think, I could literally just put this mux here. I mean, I know it's a bit awkward that we have a mux in a different place, but this saves a lot, right? And then we decide whether we're adding or subtracting using this mux. And then that's the addition, and then we have a single output here. Oops. A single output line like so. That's not... Yeah, this is looking very awkward. But it saves an entire adder. Right, and then this will go into the adder. I think this should work. Right? It's the same setup. Yeah. Okay. Yeah. I wish I could test stuff in the component factory. I wish I could write some kind of unit test for this. But yeah, I cannot really. So, alright, I'll clean this up. Something along these lines. A bit of spaghetti here. And overall, this is not a very nice and symmetric thing. But I think I'm gonna go with this, and I kind of expect to add more operations to this later. So, yeah. At that point, I might have to re-implement everything from scratch again, because this is not very scalable. But yeah, this is gonna be my, hopefully, if it works, this is gonna be my advanced ALU for now. So let's just test it over here, ALU. Yeah, and by the way, the reason it's so weirdly crammed is because I wanted to make it, you know, give it a neat shape. But let's test it. So what do I do? Instructions. Let's just try a quick wiring. Input 1, input 2, output. Except I think I might have an issue, although wait. Yeah, no, this is correct. I think this is right. Let's test. Success. Okay, so the spaghetti mess seems to work. This is the real spaghetti, not the previous level. And another thing I've been thinking is, I think it would probably make more sense to try to have a separate area in which I will do computations and logic and stuff. And this, since I do treat, so for example, I did put the clock here and input and output into this. This I might treat as my kind of register area, where stuff gets read and written. And everything else that happens in my processor should probably happen somewhere else, you know? At least that's the idea. Oops. Let's line it all up. Goodness. Like so. And yeah, I think can push it. No, like so. I think I can push it down. And then have my stuff happening above. So for now, I guess let's put our advanced ALU here. Let's bring these lines out. Yeah, this is still quite a mess. But yeah, something I really dislike is this counter line. I appreciate the counter being here. That is cool. But this line, how about I use the other direction? So this is no longer there. This is kind of my bottom lid on my processor. Nothing must go below this wire. Though of course I can scale it as much as I want downward. So yeah. Let's say this is us. Something along these lines. I might actually, you know what? Actually, I might want this up here as well. I might want to treat the counter output. No, I do not want to treat the counter output as the same because I can already load it into my input lines. So yeah. All right, now the ALU. I also don't like these cables, but I'm not sure how to deal with them yet. So let's have a perpendicular setup here. Something like so. We'll have our input, we'll have our input 2, we'll have our output, and that'll be the ALU. So, well, actually, how about a setup like this? How about, I'm not cutting this out, by the way, because I think this is kind of part of the main problem, as opposed to laying things out in the other places. And then we bring these to our ALU. Right? Oh, sorry. Wrong. Instruction 1, instruction 2. Goodness. Instruction 1, instruction 2, output. Something along those lines. And then this is gonna be our opcode. I feel like opcode is yellow. I don't know why, but I want my opcode to be yellow. And actually, I think I could... No, I don't want to color these wires the same as these ones because I don't want to mess them up. But the opcode is going to be yellow, at least for now. Okay, I think that's me. Cool. Onwards. Immediate values. All right. How do immediate values work in leg? Can go, by the way. Sometimes it is useful to load a value directly from the program instead of from registers. Sure, this is called loading an immediate value. In the leg architecture, we signal when we want to do this directly in the opcode. All right. We can do that in the following way. When the 8th bit of the opcode is green, use argument 1 as an immediate value instead of a register address. When the 7th bit, aha, okay, toggles between immediate and register values. Which, by the way, I did notice this diagram before, and it kind of has the layout of. It kind of has my old layout with ALU to the right, Okay, but wait a minute. So when the 8th bit of the opcode is green, use argument 1 as an immediate value instead of a register address. So I will want this thing, right? This is my 1. I will want it basically piped into here instead of that, right? But I think I'm gonna do it. I'm gonna do it next to my ALU, next to my AALU. Right, so I would. But then I also need to disable this decoder. Disable. Okay, so let's see. We have our opcode, which perhaps I should see. This layout is I can't come up. So I'm thinking maybe have an opcode line to make decisions down here. But then why would I have it perpendicular to all the other lines? That's weird. Yeah, then this can go away. And then I can connect like so. But again, it's perpendicular to my memory. Yeah. Maybe I should also have these ones going down parallel to everything else I have. How about that? And then I'll have them connected to here. Okay, I'll try. Right? How about this? I don't know. I don't love it, but I think this might be a better idea. Yeah, then again, then I feel like making everything parallel. So I would like to put these 3 to keep these, you know, going up, but maybe not. I don't know. Okay, so we have our opcode. We split it, and from it we get 2 things. We get immediate 1 and immediate 2, right? And now depending on what happens here, so if this is on, then we are using an immediate value instead of argument 1. So at least I want it piped into here, at least. And same thing here. I want this guy piped into here. Something along these lines. I cannot have an immediate output. But now that these decoders are disabled, I will also want to replace the input and output with the values of these things. So I know that the decoders are disabled. This means that I'm not loading from any of these switches, which means that I can just directly do the thing. I can just directly pipe my in to in and out to out. So, oh, no. This is a mess. This is such a mess because, see, okay, this is my input is gonna go here. Yes, I know. You're getting switched. Right? And my input 2 is going here. Like so. Yes, you are also getting switched. Oh, these switches don't fit. Move this over a bit. Oh, no. Yeah, so this is input 2, this is input 1. Right, and I enable input 1 like so, and I enable input 2 like so. Yeah, This is horrible. This is absolutely horrible. What do I do? How do I save this? I mean, I could make this a custom component as well, but that won't really help me that much. I don't know. But I think this is the solution. I think this should be right. This is wrong. Register 0 should have value 9, not 8. 7. Wait, but our input is 64. What is happening here? Let's reset. Register 0 should have value. Okay, let's take a look here. What is 64? 64 is just a single bit. 64. Which means we... Wait, it means nothing to me for now. I don't use that opcode ever. Right, 64 here. Not used, by the way. Is it yellow? I don't get it. Register 0 should have value 9, not 8. I loaded 8 into it. Why did I load 8 into it? Well, I go into my ALU. Wait. Oh, okay, in my rearranging, I forgot to pipe the opcode into the ALU. But we're still broken. Yeah, because this opcode means nothing to me. The opcode of 64 means absolutely nothing to me. How am I supposed to get an 8 or a 9 or anything? I don't... So, 64 is unknown, do nothing. 710. I load from 7 and from 1. So 7 decodes. Oh, input. I load from input. Okay, I guess now is a good time to talk about this. I've kind of been avoiding it for now, or until now. So I did receive a comment stating that this on switch is probably gonna bite me in the butt at some point later. And it's not entirely clear to me why that would be, but this kind of sends me off on an entire rant about what exactly input and output even means here. What is an input and an output of a processor? Why is it on or off at any point? And how does it change depending on what happens in the processor? Well, I mean, it doesn't change depending on what happens in the processor. The input definitely doesn't. But when does it change, right? In the real world, this would be I/O, I guess, or at least this would at some point meet some I/O, like a keyboard event would go somewhere and spawn some new thing. And maybe that would decide what the processor does somehow. But it's not entirely clear to me when this changes, because obviously IRL, this would just change based on time passing, right? When I press a key on my keyboard, then something is an input. Otherwise, nothing happens, no input. But in this game, of course, I get I perform no inputs. I make no inputs into this, and the inputs just come from the great beyond, whatever you call it. And the question is, how are they coded? How do these inputs work? And I think it might be implemented in such a way that the input basically changes every tick. And we have a list of all inputs for all ticks of our computer. Or maybe it changes every time I read. So there's a... would it be a stack or a queue? I think it would be a queue of inputs, right? So we'd have a queue of inputs 1, 2, 7, 25, 13, 1. And every time a tick passes and the input is on, that's when we pop from the queue. Is it a queue? I don't know. Well, it doesn't really matter. And we will no longer be... we will no longer ever read this kind of input. So yeah, perhaps this being on constantly is a problem, because at some point we're gonna read something we're not supposed to. It's gonna disappear from the queue, and we didn't need it at that point. Both of these switches might be off, and then problem. But I don't think this is the problem right now, because I do have to read from the input, so it doesn't really matter. But I could... oops. I mean, I could pipe an OR into this. Let's just check. Maybe this will fix it quickly and easily. There's no space for the OR. Whatever. I'll just do something quick. Like so. Nope, see? It's still broken. So I intend to leave this on here and find out when it actually breaks. I'll try to keep it to keep what? I don't know. I'll try to remember that this is here, and hopefully I won't get stuck forever because I forget that we have a weird on. But yeah, it should be a fairly easy fix. And I do want to know why I'm fixing it, because so far it's not entirely clear to me how the input works. So what dumb mistake have I made elsewhere? I don't understand why register 0. So we're writing to register 0, that is true. We're writing to register 0, but we aren't performing any kind of operation. Oh, wait. Sorry. Of course. No, stop. I wired the wrong bits here. Sure. It was the most significant bits, not the least significant ones. Okay. Let's fix this. Let's fix this now. It's at 8th and 7th bit, not 1st and 2nd. So, oops. There we are. Let's check now. Still broken. Why? Okay, and I think it's the other way around. I think it's the other way around. Oh no. Circular dependencies. Oh no. Oh no. Oh no. Okay, let's re-implement this from scratch. I do want to keep... Oh! Wait, I would also want to switch... I'm still gonna re-implement everything because it's probably gonna be easier, and because I actually decided I want to turn the switches over. So, 8th bit of the opcode, use argument 1. So 8th bit means argument 1 is switched. And this goes into here. Is this the way I had it originally, or is this already different? But now I also want 2 switches Where are my switches? Switch. I want two switches. Switched by these guys. So this is argument 1. So let's say argument 1. Something along these lines for now. And this is going to be argument 2. Oops. And switch them. So again, argument 1, argument 2. Now do you work? Now you do, okay. Cool. Do I clean this up? The question is, how do I? There's a problem with the fact that I have perpendicular stuff happening. I mean, I don't think there's any way to escape it. I think I will necessarily have perpendicular stuff. But I am tempted to put these guys over here. Nah, that's probably overdoing it. It's probably too much. Let's just keep it this way for now. We'll see how the architecture develops. And then I'll adapt. Okay, conditionals. Looks like it's time for us to overwrite the clock. Add if statements to your circuit. Okay. For the if statements, the two arguments are compared. And if the condition is true, the counter is set to a jump address. Okay. Yeah, so we have custom, like I can tell my program to directly reach into the counter or directly write into the counter, just using mov operations. But this looks like it's gonna be a tailor-made jump. So the previous instructions we understand. For if statements, we have a jump address. The counter is set to a jump address. So yeah, we want to put this into the counter. Oh. Oh no. Oh no. Oh. No. Okay. Jump address if the condition is true. I've already done this, kind of. If equal, if not equal, if less or equal, if greater or equal. Okay, so it looks like this requires me to build another conditional box. Right, I already have my cond. This is gonna be, we're gonna be making advanced cond. Right, this guy was comparing to 0 and it had 1 input, but we'll have 2 inputs and we'll be comparing between them, which I have done in previous levels. Right, down here I have less, signed less. Oh no. Signed less and unsigned less are different things. How do I do less? Use unsigned less. Greater for the comparisons. Okay. Each opcode does what their name implies. Sure. the following jumps to byte 16 if register 0 is less than register 1. This is, by the way, this is a curious thing. Again, I will always have multiples of 4 in here, because if I don't, then I'll have my instructions all completely mangled. And right, what used to be an output might now become an opcode. And I wonder if there's some insane assembly that makes use of this. You know, some kind of, what do you call it? Anagram? No, what's the word that reads the same forward and backward? Palindrome, I looked it up. A palindrome style assembly program that can be used in multiple ways. That would be pretty cool. Okay. So I guess let's take it in small steps and let's start by implementing our conditions box. Equal, not equal, less or equal, greater. Is that the same order as my cond, by the way? Okay, I want... so I'm gonna do a slightly different thing. I'm gonna take a screenshot of this and I'm gonna put it in my thing. Just to remember it. Now, would you stay up? Something along those lines. Sure. Now, let's go and create a new schematic. And let's start working on that. You know, I think I'm probably gonna make something completely different. So advanced cond. And I'm already second guessing myself. Two arguments are compared. Argument 1, argument 2. Yes, so I will have two inputs. I will have two inputs. And my output. No, I think I'll just have a single byte as my output. So let's see. Or a single bit, sorry. Two 8-bit inputs and a 1-bit output, but also I want opcodes to the previous opcodes, and so yeah, I will actually have 3 inputs. This is gonna be my arg1. This is gonna be my arg2. This is gonna be my cond. It's my condition. Though I could call it opcode. Alright, and this is my out. Whatever. Okay. If equal, if not equal, if less or equal, greater. Let's go back to the boxy box place. This one. What does... So equal to 0, less than 0, less than equal 0. Oh no, but I have never and always here, and here there's no such thing as never always. Which, by the way, how on earth am I gonna do unconditional jumps? I want unconditional jumps. Okay, I must be missing something else. The condition is true? No. How am I gonna do unconditional jumps? Will I have to keep... Oh, I guess I guess I can do an unconditional jump as... Wow. Oh, this is so... 37. So I do have immediate values, and I could do an unconditional jump if I just load two equal values, so like 0, 0. So I put, you know, 0, 0. No. What's... Yeah, I put my two arguments as 0, 0, and then I say if equal 32. 1, 2, 4, 8. What? Yeah, 32 is just this. Yeah, so this would be an unconditional jump. But I would also want the two arguments to be zeros. It's kind of wasteful. I don't know. I mean, it will necessarily be wasteful, right? Because I don't use arguments for an unconditional jump, no matter what those arguments are. So I guess that's it. But let's take a look, you know what? Let's also take a look at what 32, 33, 34, 35, and 36 look like. So this is 32, 33, wow. 34, 35, 36, 37. Aha, okay, no, I think it's fine. It's fine. We just have, so we have 32 as the bit that's set, and then these three decide what we want. Except there's two unused. But do I use a 3-bit decoder? Or do I try to implement little box style? Again, I keep calling this little box because it's in a little box, but actually conditions. Yeah, do I implement this style of crazy switching? Or do I go with... What? Okay, do I go with this? Not sure. You know what? Let's first try to write this out, and let's take a look at this table. So 32 is going to be 0, 0, 0, and 33 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0. Is this all? Can't quite tell because it's not lining up. 32, 33, 36. Yeah, no, I need 37, and it's an odd number, so 101. So those are my codes. Let's make them monospace. And let's try and take a look. What? Oh. I don't know what this does. Okay. It does not look like I'm gonna be able to apply the same kind of reasoning. Because it's shifted, right? If greater and if less, the difference between them is shift. If equal, if not equal, oh. Yeah, equal and not equal are negated by this one. If less or equal, no, this does not at all have the same structure that little box did, or the conditions did. So I think I'll just go with the 3-bit decoder. Besides, I think it's gonna be more readable that way. I still think that even the little box, again, the conditions level, was more readable with the decoder, even if it's not necessarily econned. Nope, no component area. We'll add some area, worry not. Okay, so let's do this. Let's bring back... No. Where's the thing? There we go. So let's take a look here. So we want. Wow, am I gonna be going back and forth and copying all of my previous solutions into here? Or should I perhaps save them as separate, whatever you call it? No, I don't think I will. So where's my equality? This is my equality. So, this is pretty huge. This is pretty huge. But yes. This is equality. Q. Not equal is okay. Less than and greater than I can derive from each other. So I only need less than and greater than. The reason why I'm probably not gonna save these things as components is because I feel like that would be slightly unfair. Okay, unsigned less is what I want. This here, huge contraption. Which I received no comments suggesting improvements on it, by the way. Christopher did say that perhaps, and it is an interesting idea, perhaps it's possible to implement the less than check using x minus y. So, you know, x is less than y if and only if x minus y is less than 0, right? And we could take this, we could kind of unfold it. We could take the definition of addition. So this is x plus minus y, right? We could take the definition of addition, take the definition of negation, come up with what less than 0 means, by the way. Although that would be simple. And reduce until we only use the necessary gates, because addition, of course, uses 1,000,000 gates. This is probably my most costly operation, I think, of everything I've done so far. And yeah, perhaps that would be another implementation, but we seem to agree that probably my solution, even though it's huge, is likely to be even more efficient than that. And, you know, it does kind of have a similarity to addition, right? We have these XORs, which are additions. We do have carry line, right? We carry. This carries upwards 1, and this keeps our carrying. So something like this might even be a result of reducing addition. But yeah, so I'll reuse these. Did I say why? I already forgot. Did I? Well, I'll just say it again. The reason I don't want to save them as separate things is because I believe it's gonna be possible to fit pretty much infinitely many gates into a single square if you just keep saving and saving and saving and saving. Although, is it possible to put custom components? Yeah, it is possible to put custom components inside custom components, which means, right, that I can take this ALU, and no matter what size it was, I can just add some, you know, inputs to it like so, and put an output, and then my ALU is just one square. Right, and the same can happen with these things, but I kind of want my component to be large to signify that it does a lot of things. So, okay, let's see here. So we have these two inputs. These are my two operations. I think I'll arrange them vertically. Maybe not. I don't know. I got stuck in that situation. It wasn't possible to easily select one of them. So something like this? I don't know. I don't know. This is looking pretty huge. Also, I don't like the gap in here. Can I perhaps do something about it? Oh, right. Now I get this full thing as a gap. Well, I can squish these in. Not sure. Whatever. Let's first wire everything into them. So let's say, line them up. First of all, let's make sure they're in line so that it's easier to work with later. And now we have input 1 going down like so, and we have input 2 going down like so, and we join it all. We connect it all. Wait, actually, I want them crisscross. Yeah, I want it to grow left to right, like so. Okay, so now input 1, input 1, input 2, input 2. I should have got this out. And then we have our outputs. So this is our equals line, and this is our... Wait. This is our equals line, and this is our less than line. Okay, so this is LT, and this is EQ. Okay. Now here's the output, and here's our condition. Yes, I'm done commenting, thank you. We want to use the 8-bit input to make a decision. So here's a question. My 8-bit input will have the 32. Do I care about it at all in this situation? Or do I use this 32 outside in my computer? So do I use this 32 to make sure I am indeed conditional? Or do I put that inside of my... So many buttons. Do I put that inside of this component? I could, for example, have... you know, another output maybe? Wait, this is a byte. I want a bit output, and I could also have a bit output like so. Signifying that, yes, indeed, we need to be in this mode. Right? Telling me that this output is legitimate, basically. I could also do a switched 1 bit and pipe this into here. And then I'll just have no output, but I don't think that will be useful because I need a positive signal from 32. I need to really make sure that I am in this mode to do some other bookkeeping. Okay, so you know what? Here's something I'm gonna do. So let's remove these, and let's put this here. Let's not worry about this for now. Let's say we are going to implement it. It should be saved as my component. Let's assume it works. Let's assume I have implemented it. And let's see what I do. Yeah, I totally want these wires vertical. Because otherwise I'm gonna have to grow to the right. And that's just not gonna be nice. I wanna grow down. I'll make these vertical. You should have seen my first Factorio playthrough. So yeah, we have this now. I also slightly rearranged this guy. And yeah, now the idea is we have the main boss. I might, if I still have the pictures or the map for my first Factorio playthrough, I might include I might include the pictures of my first base. I had a huge, absolutely massive single main bus in which every possible resource was piped. And right now what I'm doing is re-implementing that basically. Although in Factorio that was a bad idea, here I'm not so sure because we're not limited by throughput of these wires. There's still a problem of it growing sideways, but I'll deal with that later. So okay, we have our ALU, which is surprisingly much smaller than the conditional thing. Let's rewire this as well. So we have our output, pipe to out. We have our two inputs. This is our input 1. This is our input 2. Oh, sorry. Keep forgetting about the opcode for the ALU. So that's the ALU. This should be a functional ALU. Now we move down, and again we have our conditionals, and so we are told that we treat argument 1 and argument 2 is normal. So I will just pipe. This is my argument 1 and this is my argument 2, right? And then I have the opcode. This calls them instruction input 1, input 2, and I call them cond. Well, whatever. So I can pipe my opcode into here. Why do I have 3 outputs? I forgot something. Yeah, I have way too many. So let's just assume for now that I went with a single bit output, sorry, based on this condition. What else do I need to do? That's really the question. So I will want to, if this is true, so this is my output. If this thing is true, if it's, I think I might keep it yellow. Then I will want to overwrite my register, or sorry, my counter with jump address. Huh. Okay, and jump address is my output. Well, it takes the place of the output. So I'm immediately thinking, of course I can implement a thing, but I would like to perhaps just make use of what I already have. So instead of piping something directly into the counter, you know, this would be the naive solution, right? I would put this like so from here to the counter from this wire, and then I would switch this based on my bit 32, or no, sorry, I would switch this based on my I would switch this based on my result. And I would put a switch here. The fact that I'm implementing it now doesn't mean I actually intend to use it. But see, this wire is actually the same as the output. So I might as well just write to the output instead. Right? I might as well just use this to decide whether I'm going back into here. And that would be a more standard setup, right? And okay, but that's not all, is it? Because, right, because my counter also needs the override pin to be set, to be enabled. I need to enable my override pin. And that is... well, this is also decided by this. In fact, actually... Wait. No, this is completely wrong. No, this is... I mean, this is not wrong, but I forgot... First of all, I forgot a part of this. Yeah, this is that. So we will have... This is actually, you know what? This is kind of immediate mode for the output. So I could put it into here. Whoa, look how this lines up. Are you seeing this? Bit 32 is used as immediate for output. Now that is seriously cool. Nice. You know what? I love this. This looks very good. Yeah, so if we are in bit 32, then our output is immediated. Basically, jump address is used as immediate. And so now all I need to do is I don't need this anymore. Based on this single bit, I need to decide whether or not I am actually overwriting. So I will want this piped into... So again, I can, of course, do the naive thing and pipe it like so, you know? But could I maybe somehow do a... Oh, wait, I forgot an important thing. I forgot to also disable my decoder for bit 32. Yeah, that's right. I don't want to read... Or, sorry, I don't want to put anything... I don't want anything to be saved. Except I want this to override. So bit 32 is the third wire. We're just off. See? I thought maybe it would even coincide. So that bit 32 would actually... Wait, no, but this is me completely... This is completely wrong, because... Wait, or is it? Oh, goodness. I'm confusing myself. 32 is part of the opcode. It's not part of the output. Yes, of course. Yeah, so I would want 32. I would want this piped into here somehow. What's a good way to do that? Still, I'll keep this yellow. I don't know, it feels like control flow. Let me think. No, I'm afraid I don't see a better solution than this. I could, for example, do something with this byte, right? I could pipe the opcode into it instead of the actual, you know, third argument. But that would be even messier than this. And also, now that I've been staring at this for a little while, I'm also starting to see that, you know, this is kind of the construction of one module using the bus, right? This. And if you squint your eyes, this thing is, for the most part, also looking like a module. Right? I could pull these wires from down below into, you know, here. So this would be the input and output of this module. And that would be it. But there's the issue with all this is, first of all, these things are problematic. And this connection is also problematic, right? This means that my components actually have connections between them. They do not only communicate through the bus, they communicate with each other directly. I wonder if I could somehow implement bus communication protocol. Well, again, this entire thing cannot be a component, to be fair. Perhaps this could be a component, and actually, I think that's a thing Yotanido suggested. Calling it the register... what? Register... the register file, right? I could abstract this away. I'm not sure I would necessarily want to do that, especially considering the more symmetric nature of, you know, the inputs and outputs and the counter being included in this. And I don't think it would be nice to have these things separate, while these will still require, you know, most of this infrastructure. I could put the counter inside of the custom component and pipe it out, but I certainly cannot move my input and output into a custom component. That said, nah, I still think I would rather just save this once I'm sure that I don't actually need this pin and this pin. I'm still not convinced. And where was I? I was thinking about a bus protocol, but again, it doesn't look likely. I could say, for example, this as a huge custom component, but it would have so many inputs, right? It would have, yeah, it would make no sense. It would have all the same inputs and outputs. So I would still need all this, so I might as well not. Okay, well, I think let's not overthink it. Let's leave it this way for now. Just perhaps move up a bit. And let's actually implement the conditional setup. Which we left for later. Right, so I have this. I will have, as I've already decided, I'm going to have a 3-bit decoder. This is my opcode. I might want to turn it around, actually. Yeah, these large wiring projects are much harder to wire. I'm just... Okay, I'm gonna sit here for a moment, just contemplate, and I'll be back. Okay, I think an easy step I can make is just to have... Oh, this is a NOR. Wait, so is this equal or not equal? Is this EQ or not EQ? So I have XORs. So if I catch at least one green. In the output, I am not equal. I'm ignoring. So yeah, this actually means equal. Let's lay out the things I need. I have equal. I will need not equal. This is gonna be my not equal. I'm gonna need less. This is my less. Come on. I'm gonna need less or equal. So this is my equal line. I can OR it with less. Come on. OR it like so. Less or equal. Greater, greater or equal. Okay, this is less. Greater or equal is going to be the negation of less. And I also need one thing in between. I need greater. And greater is actually the negation of less or equal. I could pipe this into here. Is this an efficient way to do it? I feel like I did better for my conditions level. Not here. Here. I have an or and an and. What is this and? Greater. Greater than 0. 2 knots or and. No, I think I actually did better now. Accidentally. Did I? 3 knots and an or. Yeah. This is more efficient. Okay. Alright, so now I just need to, based on this decoder, decide what I want and pipe it into the output. How about this? Does this look good? Yeah, these designs are getting weirder and weirder with time. But I managed, I mean, part of the reason why this is so weird is because I managed to make it a relatively neat shape. Because I want to look at a nice shape. I think this should be it. So yeah, this is, you've seen this a million times. We have a decoder, we have a bunch of switches. We perform all the necessary operations, and then I guess I can, yeah, I decided white would be my 0, purple would be my less than, or not 0, equality, and then we have an output. Oh no, white is already used by output. Let's use green for equals, and white is my output, like so. Yeah, I think that's decent. I'm gonna say this is good enough. If it works, of course. Which is yet to be established. Okay, oops. Why? Should circuit inside a cond. Oh no. Wait, actually, yeah, I forgot. I think... Yeah, I want this switched, do I not? Because this will always be performed. I think I should probably make the output of acon switched based on whether we are actually, whether bit 32 is actually set. Although that shouldn't be necessary. Yes, it should, because when bit 32 is off, we're gonna have this decoder, and we might be decoding something reasonable into this line. But we're gonna be piping into it from our condition, which, why is it green with no input? Should I? I'm tempted, so I don't think it's necessary. I don't think I need it at all, but it really doesn't cost me anything to just put a 1-bit switch thing into here and just use this 32-bit. But I feel like that's the easy way out. And I'm not looking for easy ways. I'm looking to make things neat. So let's try to connect this all up. We're gonna be outputting. If we're not in 32, then we could be decoding. And yeah. Right? I have to. I think I have to make this spin gray. But now it's no longer broken. Why? So who else has access to this line? Nobody does. It's just these two guys. It's just the ACONT and the decoder. So what if we decode? Well, no, if we decode, I could try. Let me try mock input. Give me a byte splitter or byte maker. By the way, I have received complaints for not using the 8-bit constant. Oh, you said it using bits. Okay, I thought for the 8-bit constant I would have to write 67 here. And that's the reason I didn't use it, because I wanted to flip bits by hand because it's easier to debug this way. But it looks like I can. So yeah, short circuit inside ACONT. We are... Yeah, well, right now we already have an issue. We are decoding... The ACONT is spouting out junk outputs, because this is not the... The opcode is not conditioned. So yeah, definitely. I don't want it. I don't want junk outputs. That said, curiously enough, I am tempted for a real-world computer. I would be tempted to switch based on this bit 32. I would be tempted to switch off the entire thing. You know, put switches in here on the inputs so that nothing happens. Because I feel like I'm wasting calculations, but or wasting some kind of energy. But yeah, I think just a switched output should be good. And then just pipe into it like so, almost. Something along those lines, right? I'm tempted to put it here instead, so that we're not beyond this line. Okay. Right. So again, if we're 32, then we're going to be doing something. Otherwise, we're going to be doing nothing. And now we should have no short circuits from this. Wait, my ALU is also not switched. But I think my original ALU was switched. I think I need the ALU switched as well. No? Wait, how come? How? Does nobody else write? I think we're gonna have a short circuit here as well. From this switch, if we have bit 32... Wow, this is... Okay, let's try a mock input. This is complicated. There's so many things to consider. Let's take a quick look at our original ALU, which I didn't design myself. This output is not switched. But I think that's because I only piped the ALU. Or, oh, actually, I remember now. I think I had a switched past the ALU. I think I put in an ad hoc switch. Where's my overture? Yeah, I have an ad hoc switch here. And decode. Oh no, this is no. No. I don't even want to look. Let's make a mock input again. So let's see. I want bit 32 to be set so that this switch works. Right? Let's set bit 32. Oh no, I have another short circuit. Why? Disable. How is this? I disabled the decoder. Does disabling the decoder just make all pins? Oh, it makes all pins. It makes all pins off. It doesn't disable them. It doesn't make them green. It makes them red. Or it doesn't make them gray. It makes them red. So that's an issue as well. Okay, but let me still, I want to test the ALU. So 32, and let's give it some opcode. What opcodes do we accept? Yeah, first let's just do... Oh, this is complicated. This means we're going to be doing addition, right? Yeah, 1 addition. No, 0 is addition, sorry. 1 is subtraction. So let's do addition, and let's also have stuff like this. Oh, oh no. This is not good. Wow, this is complicated. I want to create a short circuit in here. I want to add something, but I would like to add just direct values. So let's say let's just operate entirely. Okay, we're already broken. Yeah, see? This switch and this ALU are in conflict. Because this guy adds 32 and 32. And this guy tries to output. Let's put something simpler, like, or more recognizable. Let's put 7 and 15. Right? This guy is trying to add up 7 and 15, gets 22. But this guy, since it's on, tries to overwrite using this bit, or using this byte. And this byte could also be something. Whatever. Right? And this is a problem. Except, see, I removed some wire to fix it, and now I don't remember which wire I removed. Which wire? Oh, this one. Right. Yeah. Switch tells me 23. And ALU tells me 22. So I might want to also switch my AALU. But the question is, can I even do it? There's no specific bit to decide whether I am in ALU mode or in... These might be... So I might be considering malformed instructions here. But I don't think... First of all, I don't think there's actually such a thing as a malformed instruction in assembly. And second of all, even if the programmer somehow manages to give me a malformed instruction, I don't think the computer should burn up. Right? It should not catch on fire. We do not want a short circuit under any circumstances. So how do I even... Yeah, the ALU... I will need to disable, so I pretty much need to disable the ALU if this switch is on. Otherwise... And I think that's probably what I do in Overture. I think that's what I did in Overture. We have this immediate calculate. Oh, we had a mode. We had a calculation mode. So we Yeah, we didn't have this problem, but now I do have this problem, and it's bothering me. Oh, right, switch schematic, like... This is bothering me, and this is, I mean, this is a byproduct of my reliance on these 3 wires on the bus. I am very much tempted to make all my outputs gray. I would like to make this guy... Oh, this guy's already gray. Yeah, I already did that. So... Where am I? Why not make the AALU gray as well? And in fact, why stop there? I think I might even want to make these decoders gray so that I don't have this problem right here. Well, this should be pretty cheap, pretty easy to do. I have my byte output. Let's turn it into an 8-bit. An 8-bit switched output. And let's use bit 32. Same thing, except I have no space left. How do I... Okay, I can just about squeeze through here. Alright. So, yeah, except I need it negated, I believe, right? Which this is actually gonna make my ALU look nicer. This square is now not empty. I'm happy about that. So, yeah, now I have my ALU switched. And we shouldn't have a problem, except we still do. Why? Bit 32? Wait. Yeah, no, if I enable bit 32... What's up? No, this is okay, because I forgot to disconnect the program. Yeah, see, now my ALU is turned off, and I'm free to do whatever shenanigans I'm up to. Okay, and now about these decoders and this problem. I think, for now, just for this video, because it's already the longest one I've done ever, again, man, duration inflation happening here. I think I would like to just make a temporary workaround, because I don't want to design a whole thing like that right now. So instead, I will just pull this out. So remove this, pull this guy out so I can see it. Pull this guy out as well. Right, and then based on my 32-bit, based on this, I can decide whether my output is this guy or this guy. So that should be a mux, right? Like so. Something along these lines. I think this is correct. Yep. Wait, what? Yeah, this is correct. So just to reiterate, this is definitely temporary until I resolve the issue with my decoders, but I think this should work. As in, this should actually pass my test for conditions. Yep, there we go. Cool. Congratulations, I finished the leg computer. Oh, thank you. That was easy. I still have an unused bit. I will show you some upgrades you can make. Okay. I think the bit will get used. The this bit, 16 in the opcode is never used. Because I have 3 bits for opcode. Well, for the code itself, right? I have 3 bits in here. Gate score! I unlocked gate scores. 146, 48. A switch is 8 gates? No way, that's too much. Oh, actually, yeah, this is an 8-bit switch. Okay, 8. What's up with this 8? Did I unlock a 1-bit switch? Well, I always had a 1-bit switch. Everything changed. Wait a minute. Finish the leg computer. I will show you some upgrades you can make on the path to implementing function calls. But from here on, the details are up to you. I won't tell you what opcodes to use and so on. Alright. See, I still don't copy. It's just add with the second argument being 0. Huh. I mean, thanks for the tip. I kind of would have liked to come up with that myself also. Right, I thought I unlocked a NAND gate. But in fact, I have now unlocked gate scores. Alright. Well, no. I'm still gonna leave leg slightly unfinished, even though I'm told that I'm done. There's 2 hanging issues. There's this, which is this, and there's this part. As well as implementing these guys differently, possibly encapsulating this, or possibly just this, or possibly this. We'll see. Yeah, but other than that, this is looking pretty clean. I'd say this is pretty good. And it can be even better. So, yeah, I'm excited to make it better. Next time.